Good day, everyone. This is Master Manuel. Today we're going to learn about addition and subtraction of different number system. We have the binary numbers, we have the octal numbers, and we have the hexadecimal numbers. First, let's learn about binary addition. Okay, so we have an example here. We have 1101 plus 1011. Okay, the things that we have to remember is that binary has two numbers. Always remember that. It only has 0 and 1. Okay? So look at this, 0, 1, and 2. Okay, instead of putting 2, we will have to put 0 because remember, binary has only two numbers, okay, only 0 and 1. Okay, so here's how to count a binary number. 0, 1, after 1, it restarts counting from 0, 1, 0, 1, and so on and so forth. Okay, the rule in binary is 1 plus 1 is equals to 0. Why? As I told you a while ago, we cannot put 2. Right? Because it only has 0 and 1. So we put 0 instead and we carry 1 to represent a bigger number than 1. Okay, so here's our example. Okay, so 1 plus 1 is equals to 0. Carry 1. Okay, 1 plus 1 is 0. Carry 1. 1 plus 1 is 0. Carry 1. 1 plus 1 is 0. Plus 1 is 1. Carry 1. Bring down 1. We get 11000 as our answer. Now let's learn about binary subtraction. So here's our example. We have 1101 minus 1011. So let's put it down. All right, so 1 minus 1 is equals to 0. 0 minus 1 cannot be because 0 is smaller than 1. So we will have to borrow from 1 over here. So we cancel 1, 1 becomes 0. So how many numbers can we borrow from 1? If you can remember, binary has two numbers. We have 0 and 1. We have 0 as the first number, and we have 1 as the second number. So we can borrow two numbers from 1. So we cancel 0, it becomes 2. Okay, 2 minus 1, we get 1. Okay, 0 minus 0 is 0. 1 minus 1 is 0. So the answer is 0010. Next, let's learn about octal addition. So here's our example. We have 4257 plus 5650. As you notice, there's no number bigger than 7, as 7 is the last number in octal number. Okay, things to remember. Octal has 8 numbers, 0 to 7. 7 as the last number. Okay, so we have 0, 1, 2, 3, 4, 5, 6, 7. 8. Do we have 8? No, so we stop from 7. Okay, and then start counting from 0 again. 1, 2, and so on and so forth. Okay, so let's put this down. 7 plus 0 is equals to 7. 5 plus 5 is equals to 10. But remember, in octal number, we only have 0 until 7. So we cannot put 10 here. Alright, so 5 plus 5 is equals to 10. Okay, octal, 8 numbers. So what we have to do is 10 divided by 8. Okay, 8 numbers in octal. We get 1. Remainder 2. Okay, so the remainder goes over here. And 1 goes over here. Carry 1. Is it clear? Now let's move to the next one. 1 plus 2 is 3. Plus 6 is 9. Okay, in octal, we only have until 7. So it's the same procedure. We have 9 divided by 8 is equals to 1, remainder 1. Remainder goes over here. And 1 goes over here as our carry. Okay, carry 1. 1 plus 4 is 5. Plus 5 is equals to 10. It's the same thing. Okay, so we cannot put 10 here. So what we do is 10 divided by 8 is equals to 1. Remainder 2. Remainder 2 goes over here. And 1 over here goes as our carry. Okay, carry 1. Okay, there's no number here anymore, so put down 1. So the answer is 12127. Next, let's learn about octal subtraction. So here's our example. We have 4260 minus 653. Okay, so let's put it down. Okay, 0 minus 3 is not applicable as 0 is smaller than 3. So we will have to borrow from 6. So we cancel 6, 6 becomes 5, and 0 becomes what? If you can remember, in octal number, we have 8 numbers, 0 to 7. So if we borrow from 6, how many numbers can we get? Okay, we can borrow 8 numbers. So we cancel 0, it becomes 8. Okay, 8 minus 3 is equals to 5. All right, 5 minus 5 is 0. 2 minus 6 cannot be, so we will have to borrow from 4. So we cancel 4, 4 becomes 3, and 2 becomes what? Okay, we can borrow 8 numbers from 4, so 8 plus 2, it becomes 10. Okay, so 10 minus 6 is 4. 3, there's no number here anymore, so bring down 3. The answer is 3405. Next, let's learn about hexadecimal addition. So here's our example. In hexadecimal, we have numbers and letters. Okay, so here it is, A9D2 plus 0F57. This is what you have to remember. Hexadecimal number is equals to 16 numbers. We have 0 to 9 and A to F. Okay, so we have these numbers and letters. Do we have G? No. Okay, so it ends at F. Okay, after F, it resumes or restarts counting from 0. 1, 2, 3, so on and so forth. Okay, so the last letter in hexadecimal is F. Okay, so here it is. Let's put it down. Okay, so 2. So the first thing that we have to do here is convert these letters into numbers. Okay, if you can remember, A is equivalent to 10, B is 11, C is 12, D is 13, E is 14, F is 15. So we cancel out A, we put 10, okay, as A is equals to 10. We cancel out D, okay, we put 13. We cancel out F, and we put 15. Right? So 2 plus 7 is equals to 9. Okay, 9 is still inside the 16 numbers. Okay, it is the last number over here. Okay, so we can just put 9 over here. 13 plus 5 is equals to 18, right? But in hexadecimal, we only have 16 numbers and only until 9. So we cannot put 18 here. So what we have to do is 13 plus 5 is equals to 18. Okay, hexadecimal, 16 numbers. So we put down 18 divided by 16. We get 1. Remainder 2. Is it clear? Remainder 2 goes over here. And 1 over here goes as our carry over here. Okay? Next, we have 1 plus 9 is 10, plus 15 is 25. It's the same. We cannot put 25 here as we only have 0 to 9 until 9, and hexadecimal is 16 numbers. So it's the same procedure as this one. We put 25 over here, divided by 16. We get 1, remainder 9. The remainder goes over here, and 1 goes over here as our carry. Is it clear? Now let's move on. 1 plus 10 is equals to 11. Okay? In hexadecimal, we only have 0 to 9. Okay, so we will have to convert 11 as a letter over here. So 11 is equivalent to B. So the answer is B929. Next, let's learn about hexadecimal subtraction. So here's our example. We have A9D1 minus B5A. So here's the thing that you have to remember. Hexadecimal is equals to 16 numbers, 0 to 9 and A to F. Okay, so we have these numbers and letters. Okay, G, we don't have G as it ends at F. Okay, and resumes counting from 0, 1, 2, 3, 4, and so forth. Okay, so let's bring this down. A9D1 minus B5A. First thing that we have to do is let's convert all the letters into numbers. If you can remember, A is equal to 10, B is 11, C is 12, D is 13, E is 14, F is 15. So A is equivalent to 10. So let's cancel it out. Let's put 10 here. D is equivalent to 13, so cancel. Put 13 over here. B, cancel. put 11. A cancel, put 10. All right, so let's start subtracting. Okay, so 1 minus 10 is not applicable as 1 is smaller than 10. So what we have to do is borrow from 13 over here. So we cancel 13, 13 becomes 12, and 1 becomes what? How many numbers do you think we can borrow from 13? Do you remember in hexadecimal we have 16 numbers? So we can borrow 16 numbers from 13. So 1 becomes 1 plus 16, it becomes 17. So we cancel 1, it becomes 17. Right? 17 minus 10 is equals to 7. All right? 12 minus 5 is equals to 7. 9 minus 11 is not applicable as 9 is smaller than 11. So we will have to borrow from 10. We cancel out 10. 10 becomes 9. And then how many numbers do you think we can borrow from 10? As you can remember, hexadecimal contains 16 numbers. So we have 16 numbers plus 9 is equivalent to how much? It becomes 25. All right? So 25 minus 11 is equals to 14. Okay? As you can remember, in hexadecimal, we only have 0 to 9. So we will have to convert 14 to a letter. So where it is, it's over here. So it is equivalent to letter E. All right? So 9, there's no number here anymore. Just bring down 9. So the answer is 9E77.